Hello, my dear students. I hope you all are today. In this video, I'm going to explain about grade 7 lesson 2 static electricity. Or we will see the meaning of static electricity. Before that, we should know what is charging an object. When some objects are rubbed, electrical charges are generated on them. When they are rubbing together, the charges are generating on them. Electrical charges generated on the surface of objects by rubbing are called static electrical charges. This is a practical we can do. Cut several small pieces of dry paper and place them on a table. Rub a plastic pen against your dry hand. Fold them on the pen, close to the piece of paper. Then the observation is pieces of paper are attracted to the pen. You can see as in the picture, the pieces of paper are attracting to the pen, the rough pen. Conclusion is the light things attract towards an object which is rubbed against some other material due to static electric charges generated when rubbing. That is the conclusion we can take from this practical. The scientist William Gilbert was the first who revealed that light things are attracted to dark objects. There are two types of static electrical charges. One is the positive static electric charges and the negative static electrical charges. Objects with like electric charges repel it. Like means same. Positive, positive repel. Negative, negative repel. And objects with unlike electric charges attract each other. Unlike means different. Negative, positive, they attract each other. Generation of static electrical charges. The amount of positive and negative particles are equally distributed on an object before it is rubbed. Before we rub an object, the amount of negative charges and the amount of positive charges are equal. Therefore, the object does not show any net charge. When we are looking at from outside, we can't see any charge in that object. When the objects are rubbed against each other, negatively charged particles, that means electrons, negatively charged particles in an object is the electron. Then they remove from one object and transfer to the other object. The object from which negatively charged particles are removed is charged positively because previously there was similar number of positive and negative charges in that object. Now some amount of negative charges are removed from that. So now it has a positive charge because now there's net positive charges on that object. And the other object get a negative charge because now it has extra negative charges that has come from the previous object. I'll show this by using picture. When two objects are rubbed with each other, one object is positively charged while the other is negatively charged. Now I'm going to explain that situation by using the picture. Let's consider Consider that in this cloth, there were similar number of positive charges and similar number of negative charges. I will show 4 positive charges and 4 negative charges. Now, when we are looking at it from outside, we can't see the net charge because same number of positive and negative charges are there. But when we are rubbing these things, when we are rubbing this cloth with a glass rod, this glass rod is rubbing by using the cloth. Then from the glass rod to the cloth, some negative charges are removed from the glass rod. Some negative charges are removed. Previously, in the glass rod also there is similar number of positive charges and negative charges. And 5 positive charges and 5 negative charges were there. Now from that 3 positive negative charges has removed from that. Then consider that if it has 5 negative charges. Now 3 negative charges have removed. Now there's 2 extra positive charges. That is why the glass rod is charging positive. And previously, there were similar number of positive charges and negative charges in the flow. But now it has 3 extra negative charges. Because of that, it has charged negatively. This is how the objects are charging when they are rubbing with other things. So in the next slide, when a glass rod rubbed with a silk cloth, glass rod gain positive charge. When an ebonite rod rubbed with a wool, ebonite rod gain negative charge. When an ebonite rod rubbed with a silk, ebonite rod gain negative charge. When a glass rod rubbed with a wool, glass rod gain positive charge. You should know these combinations well. Testing the neutralization of charge object due to the exchange of static electrical charges. Let's see this activity. You have now a silk cloth against the glass rod and rub the woolen cloth against the ebonite, and the two rods separately on two stands with pieces of threads. You can see one is positively charged, the other one is negatively charged. Bring two rods close to each other's slot. You have to bring them together. Refer the observation. What's the observation? You can see both glass rods are attracting each other because you know positive charges and negative charges are attracting together. Repeat the previous step several times and observe what happens. When you are doing it several times, you can see as in the picture, these negative charges are discharging with positive charges. So after we are doing this in several times, we can see that attraction is not happening. You see the observation given here. Positive and negatively charged rods attract at the first time when they are brought closer, not close to each other. But they neither attract nor repel when they are brought together repeatedly. The reason for this is that they are neutralized because of exchange of charges at the first point. Neutralized means combining the negative and positive charges and is no any charge after that. Neutralizing, combining the negative and positive charges and discharging. That is the neutralization. When after they are neutralized, uh, in the first attraction, no any charges to attract again. Phenomena associated with static electricity. First thing is lightning. Lightning occurs because of the generation of static electrical charges on clouds. On clouds, how the static electrical charges are generated? Static electrical charges occur on tiny droplets of water on clouds because of their collisions with each other. Collisions are happening in between each other when the static electrical charges are created. Thus, static electric charges collect on the cloud and the cloud becomes charged. The sudden discharge of electric charges accumulated in a cloud to another cloud to the earth as a spark is known as lightning. You know, lightning is like a spark. That spark is occurring mostly because of the discharging of the positive and negative charges. That means from one cloud to another cloud, positive and positive charges are discharging. Sometimes from one cloud to the earth, this discharging is occurring. Anyway, this is how the lightning is occurring. The reason is the static electrical charges. Electric sound when iron clouds. Sometimes you may observe that the hair on your arm is attracted to silk cloth, giving a thick sound when you iron them. The reason for this phenomenon is the generation of static electric charges when iron comes into contact with silk cloth. It is also a type of rubbing. So static electrical charges are generated in the cloth. That's why we can hear a tick sound when we are so close to that silk cloth. Attraction of hair on the arm towards the TV screen. Sometimes you may have experienced that hair attracts to the TV screen when TV is switched off. The reason for this is the accumulated static electrical charges on the TV screen. Some other instances in photography machines, in radio and television. Next topic is the capacitors. The appliance that can store static electrical charges is known as capacitor. In that instrument, we can store charges. Storage of static electric charges in a capacitor is known as charging. And releasing the charges from the capacitor is discharging. Charging and discharging. The amount of electrical charges that can be stored in a capacitor is measured in farad. That's the unit that we are measuring the amount of charges in a capacity. Farad symbol is capital F. Another unit is subunit is microfarad. You can see this number that also. Here's another activity. Identification of charging and discharging of a capacitor. You will need 1000 microfarad capacitor, 3 dry cells, a small LED bulb, pieces of wire. Connect pieces of wire to the terminals of the capacitor. Connect the other ends of the wire to dry cell correctly. After a few seconds, remove the dry cell and connect the LED correctly to the capacitor and also discuss the reason of your answer. Let's see the quiz. The reason of lighting of LED is discharging of charges stored in the capacitor through LED. In the first instance, we have connected the capacitor to a dry cell. While we connect a dry cell to a capacitor, the capacitor is charging by storing more charges in them. But after we connect it to the the LED is taking these charges and gradually the capacitor is discharged. Capacitor can be recharged by connecting it correctly to the dry cells again. After connecting it again to a dry cell, we can store more charges in that. We can light the LED again. This is the end of today's lesson. If you have any problem in any lesson, you can request me to do any explanation. Request me to do the explanation of that lesson by commenting the lesson to the comment section. And, if you want to see more videos like this, subscribe the channel and click the bell icon to watch more videos like this.